Students, will continue with the next topic, that is work done by a constant force. Okay, now in scientific language, okay, we have already seen what is work done. Okay, now to be work done, you need two things. I'll have a very quick recap. A force should act on the object and then object should be displaced. So these two things should be done. So a constant force F, okay, that should act on the object and the object should be displaced through a distance S. So two things are there. First is the force F and then is a displacement by distance S. Okay, now let W be the work done. So if work done is W, then the formula is force into displacement. F force into S displacement, that is F into S is equal to work done. Okay, because of these two conditions, that is force into displacement. So whenever you are displacing some object by a distance S and you are applying the force from here, then the work is said to be done. Okay, now work done by the force acting on an object is equal to the magnitude of force. What is the meaning of this? It means that how much ever the value of the force, that much the work will be done. If more the force, more work will be done. Less the force, less work will be done. And then it has to be multiplied by the distance which is moved. And this all should be in the direction of the force. The work done should be always in the direction of the force. Okay. Now work is a scalar quantity. So there is only magnitude, no direction. Now if we have got 1 Newton meter, okay, that is 1 Newton multiplied by 1 meter. The force is equal to 1 Newton, displacement is equal to 1 meter, then the work done will be 1 Newton meter. This is the unit of work, that is Newton meter. Now this Newton meter is also called as joules. Okay, this is in the memory of the scientist Joules. So Newton meter is also represented by capital J, that is joule. Now what is joule? Now if we have to do 1 joule, what is 1 joule? Then 1 joule means you will have one force of 1 Newton acting and the displacement will be 1 meter. You can just turn the page and see here. The force of 1 Newton displaced by 1 meter. This is 1 joule. Now what would be the work done when the displacement of the object is 0? There is no displacement. Can you consider work to be done? Okay. Now let us see, there is an example here. Now in this example you have got 5 Newton force acting and the displacement is 2 meters. Okay, so what is the work done? 5 Newton into 2 meters, you will get 10 Newton meter, that is 10 joules. Okay, fine. Now there is one question here. Now if you have got 7 Newton, 8 meter displacement. So 7 multiplied by 8, that is 56. So 56 joules will be the work done. Fine. Now the next question is a situation in which force and displacement are in the same direction. We have got so many examples, like a baby pulling a toy car. Okay, we have got so many examples for this. If the situation work done is equal to the product of force and displacement. Now in such situations where the force and the displacement are in the same direction, then the work done will be always positive. It will be always positive. Okay. Now we have another situation, okay, where the object is moving in a particular direction but the force is in the opposite direction. That is known as a retarding force. Okay. Now whenever you have a retarding force, there will be an angle between the two directions. So there will be two forces acting actually. One will be a stronger force, one will be a weaker force, and the object will stop after the displacement after some time. Okay, now here what happens? You will have negative displacement or negative force. Okay, so the value of the work done will be negative. When you have got force acting in the opposite direction, that is called as retarding force. Okay, so work done will be negative when the force acts in the opposite direction of the displacement. and work done is positive when the force is in the same direction of the displacement. Okay, we have another example here where you have got 15 kgs which the porter has to lift from the ground and put it on his head, that is 1.5 meter above the ground, and you have to calculate the work done. Okay, so here what we have got, the directly F is not given to you, mass is given to you, and we know that F is equal to m into A. Okay, so here it will be, instead of A it will be gravitational acceleration G. So F is equal to mg, that we all know. So 15 into 10, because G is equal to 10 meter per second square, that we all know. Okay, so take the value G as 10, multiply it by 15, and then displacement is 1.5 meters, so multiply it by 1.5. So multiply all these three things, you get 225 kg meter per second square, that is 225 Newton meter, that is 225 joules. So work done is 225 joules. In this question, force is not directly given to us, mass is given to us. So whenever such questions are there, when you are only mass is given, you have to take G as 10 meter per second square, that is gravitational acceleration. Okay, thank you.